Hello friends, so here is another question on electric charge and Coulomb's law. So here in this question it is given that 3-point charges each of value plus 5 microcoulomb are placed at the vertices of an equilateral triangle, and the sides of the equilateral triangle it is 10 centimeter long. We have to find the force on each of these charges. Okay, so let us try to draw the diagram from the data which is given. So let us say we draw a equilateral triangle. Okay, this A, B and C, plus 5 microcoulomb, plus 5 microcoulomb, plus 5 microcoulomb. Now as it is an equilateral triangle, the angles are 60 degree, we all know that. Now the force acting on any of these three charges, they are equal. The net force acting on any of these three charges which are placed at A, B and C, it is equal. Why? Because all the three sides are equal, angles are equal, magnitude of charge plus 5 microcoulomb, that is also equal. So if we pick any of these one particular points and find the net force acting on it, that will be the force acting on other two charges as well, other 2 points as well. So let us say we pick point C, okay, plus 5 microcoulomb at C. So here there are two forces acting on it, okay, two forces acting on it. First one is FCA, okay, this FCA, the force between charge placed at A and charge placed at C. Another force is FCB, this, okay, FCB, the force acting between charge placed at B and charge placed at C. So it is like this: point C plus 5 microcoulomb, this is FCB, and this is FCA, and this angle is equal to also 60 degree, okay, because these two angles they are always equal, okay. So this is also 60 degree. So now let us try to find out FCA and FCB. It will be equal, okay, because these are all 10 centimeter, this is also 10 centimeter, separation distance is same, magnitude is same. So FCA equals to FCB is equal to 1 by 4 pi epsilon 0 5 microcoulomb into 5 microcoulomb by 10 into 10 to the power minus 3, that is 0.1 square, okay, 10 centimeter it is, so 0.1 meter. So if we calculate it, it is 9 into 10 to the power 9, 5 into 10 to the power minus 6 whole square by 0.1 whole square, that is equal to, it is coming around 22.5 Newton, okay, FCA and FCB, that is equal to 22.5 Newton. But here we will be using the concept of vectors to find the net force. Now we have already discussed in vector algebra that let's say we have two vectors, okay, that is P vector and Q vector. Okay, it has an angle theta. So the resultant of these two, it has a magnitude equal to root over P square plus Q square plus 2 PQ cos theta, isn't it? This is the magnitude. So here we have to find out this resultant force acting on C, the resultant force acting on C. So the resultant force acting on C here will be Fc vector magnitude is equal to Fcb whole square plus Fca whole square plus 2 Fcb Fca cos 60 degree. Now as it is equal to 22.5 Newton, we can write it as F, let's say, okay, F, okay. So that is equal to F square plus F square plus 2F square cos 60 degree. So we have replaced Fcb, which is equal to Fca, as F, okay. Here we'll put the value of 22.5 Newton later, root over of this. So this is equal to 2F square plus 2F square cos 60 degree, which is equal to 2F square into 1 plus cos 60 degree. We can express it as root over of 2F square into 1 plus cos 2 into 30 degree, okay, this 1 plus cos 2 theta. Now you know 1 plus cos 2 theta is equal to 2 cos square theta, okay. So we'll be using that. So we'll get 2F square into 2 cos square 30 degree. So it will be, finally the value will be 4F square cos square 30 degree. So which is equal to 2F cos 30 degree, which is equal to 2 into 22.5, which we calculated here, Fcb Fca equal to 22.5 into cos 30 degree, and that is equal to 38.97 Newton. This is the resultant force acting on C, okay. The resultant force magnitude acting on C is 38.97 Newton. Okay, so here again basic application of Coulomb's law and some basic conceptual understanding of vector algebra, we used it to get the result, okay. This is the result. The net force acting on the charge C is 38.97 Newton, and that is also equal to the net force acting on B and the net force acting at point A, because it is an equilateral triangle where all the sides are same, which means separation distance between charges is same. Magnitude of the charges placed at these three vertices, that is also same. It means the net force acting on each of these points, it will be same, that is equal to 38.97 Newton. Okay. Hello friends. So here we are with another question on electric charge and Coulomb's law. So here the question is that we have two small spheres, each having a mass of 0.1 grams, and they are suspended from a point with the help of threads of length 20 centimeter, okay, 20 centimeter long threads. They are equally charged and they repel each other to a distance of 24 centimeters. What is the charge on each sphere? Okay, so this is the data that we have. Now with the help of this data, we will be first, the most important part of this question is to convert this data into an accurate diagram, figure. So let us do that. So we have, okay, this point here, and we have two spheres. Okay, two spheres suspended from a point. Now these two spheres, they repel each other to a distance of 24 centimeters. This is 24 centimeter, and the length of the thread is 20 centimeter. Okay, this length of the thread. Now here we have to consider each sphere first. Okay, so let us convert it into two parts and be focusing on only one part. So this part, as it is in the middle, so this will be 12 centimeter. So let us consider this sphere, okay, this sphere. So this sphere here, if we consider this part only, here there are a number of forces acting on it. First, there will be the electric force, the Coulombic force, which is the repelling type. So here it will be like this because of this sphere, and because of this, the repelling force, this will be the electric force. Let's call it F. So we'll be denoting here it also F. It is the electric force of repulsion acting on this sphere. We are only considering this for easier analysis. Then there will be a tension force acting on the string along the length of the string. Okay, this is the tension force, capital T. Let's say this string, it makes an angle theta along the horizontal. Okay, let's say this string, it makes an angle theta here. This is the angle. So if we resolve this tension force in two parts, into two components along the horizontal and vertical direction, we have this one, T cos theta acting along the horizontal direction and T sin theta acting along the vertical direction. This, and then we have the gravity force, the weight of the sphere, mg, acting on it. So these are the forces acting on the sphere, each sphere. So we have taken, this is the same for this sphere also, but we have taken only this. Now let us assign the points because we will be needing it. Let's say we call it A, we call it B, we call it this point C, and this midpoint as D. Now here, this is a right angle triangle ABD. So here AB is 20 cm, BD is 12 cm. We have to find AD. AD will simply application of will apply the Pythagoras theorem. So that will be AB square minus BD square, which is 20 square minus 12 square, that is 400 minus 144 root over of, I think it will be 256, and it will be 16, I think, yes. 144 minus 400, 260, yes, 16 it will be. 16 centimeter, that is the length of AD. This is 16 centimeter. Okay, now here if we, this is the equilibrium position, okay, as it is repelling each other to this distance, this is the equilibrium position. Now here if we see the horizontal and vertical forces that are acting and we balance them, here F will be equal to the electric force of repulsion, that will be equal to T cos theta, equating the forces in the horizontal direction, and mg will be equal to T sin theta, because this is the equilibrium position. Okay, so now T sin theta by T cos theta, that is equal to, T will get cancelled and it's only be tan theta, that will be equal to mg by F. Okay, mg by F. Our objective here is to find the charge on each sphere. So for that, first we have to determine this electric force, because then we can apply Coulomb's law to get it. So F is equal to, here F is equal to how much? Mg by tan theta. Okay, so tan theta here is equal to, if we look at this point, tan theta perpendicular by base, which is equal to AD by BD. Tan theta is equal to AD by BD, which is equal to 16 by 12. 16 by 12. So here it is mg by 16 by 12, or we can say it is 12 by 16 into mg. Okay, so this is the electric force. F is equal to 12 by 16 mg. Now we know that electric force between two charges, that is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. Here both the charges are identical, they are equally charged, so we will substitute this with 1 by 4 pi epsilon 0, let these two charges, identical charges, be small q, it will be q square by the distance of separation is how much? 24 centimeter. So it is 24 centimeter. So it will be 0.24 whole square. Okay. So if we substitute 1 by 4 pi epsilon 0 with 9 into 10 to the power 9, it will become even more simple. So let us cut this and substitute it with 9 into 10 to the power 9. So this will be 9 into 10 to the power 9, 1 by 4 pi epsilon 0. That is equal to 12 by 16 into the mass of the sphere is 0.1 gram. Converting it into kg, it is 0.1 into 10 to the power minus 3 kg. Acceleration due to gravity is 9.8. That is equal to this. That implies q square is equal to 12 by 16 into 0.1 into 10 to the power minus 3 into 9.8 into 0.24 whole square into 1 by 9 into 10 to the power 9. This. So q square is equal to this much. So if we calculate, this is coming around 4.8 into 10 to the power minus 15, that is q square. Okay, this is equal to q square. Q is equal to the root over of this much, and that is equal to, it is coming 6.92 into 10 to the power minus 8 Coulomb. So here is the solution that we wanted. Okay, we wanted to find out the charge on each sphere. So this was a very good question because it involved the application of a lot of other concepts also. So it was kind of an indirect question where the principles of mechanics also came into play, along with electricity and magnetism. So here basic principle of electric charges combined with mechanics, everything combined into one single problem. Okay, so the first and most important thing here is to convert the data which is given in the question, understanding it, and then converting it into a accurate figure. Okay, so once you draw the diagram, then you can understand the question in a better way. Next was simply resolving the different forces acting on each sphere into different components, horizontal and vertical, equating them, and then you get the solution. Simple mathematical calculations. Okay,